For as long as we've looked up at the night sky, humanity has been haunted by a single question. Can we ever leave, not just Earth or the solar system, but the Milky Way itself, the immense spiral of stars that defines our cosmic address? It feels inevitable. Explorers crossed oceans, rockets broke free of Earth's pull, surely one day we'll break the last horizon. Yet physics answers with a colder truth, because the Milky Way is not a stepping stone, it's a prison, a beautiful glittering one whose bars are carved into space-time itself. The first trap is scale, real, crushing, unforgiving scale. Because when we say galaxy, we nod sagely and move on, forgetting what vast actually means in numbers that bruise the mind, like a disk roughly 100,000 light-years across, with our sun skimming along one of its spiral arms while everything orbits the dark heart at the centre. Consider our farthest messenger, Voyager 1, the tiny metal pilgrim that has been travelling for nearly half a century, now more than 160 to 170 astronomical units from the Sun, racing at around 17 kilometers per second, and yet, in galactic terms, it hasn't left the driveway, not even the neighbourhood, not even the street, because at this pace it would need tens of thousands of years to cross just a fraction of the local bubble, never mind the galaxy's disk. But distance is only the beginning. The real wall is gravity, the soft hand that never lets go, because every star, gas cloud, and invisible halo of dark matter weaves a shared potential well, all of it folding us inward towards Sagittarius A star, the supermassive black hole at the Milky Way's core whose mass, about 4 million suns, anchors the central swarm and helps define the orbits that keep us captive. Escaping that well is not like beating Earth's 11 kilometers per second, or even the Sun's roughly 600 kilometers per second at our orbit. It's a steeper bill. The local galactic escape speed near the Sun is measured around 500 to 600 kilometers per second, depending on method and radius, a number large enough to turn engineering into wishful thinking, and small enough to lull the imagination into thinking it's merely fast, when in truth it's a wall made of energy budgets we cannot pay. Put Voyager beside that number and feel the gap, 17 kilometers per second versus roughly 550, the difference between a strong wind and a hurricane of motion, between a heroic sprint and the speed needed to outrun an entire galaxy's pull, which is why no human-made object is on an escape trajectory from the Milky Way, and none will be for a very long time. Hypervelocity stars show what it takes. Rare outcasts flung by gravitational slingshots near the central black hole at well over 1,000 kilometers per second, bullets of starlight barely making the grade, evidence that the galaxy does let go sometimes, but only after violent, precise encounters with its monster at the centre, not through gentle, planned departures. Now add Einstein's tax. Go faster, pay more, because as velocity climbs toward light speed, kinetic energy costs surge non-linearly, and relativity piles on with ever-growing effective inertia, meaning each extra millimetre per second closer to CC demands disproportionately more energy, turning starships into energy debts that rival stellar output if we dream of significant fractions of light speed over macroscopic masses. Even if some miracle engine pushed a craft to a meaningful fraction of CC, the interstellar medium stops being empty and starts acting like sandpaper made of bullets, since dust grains and sparse atoms become high-energy projectiles at relativistic speeds, demanding shields so massive they suffocate acceleration, a paradox engineers know too well. To survive, you must be heavy. To move, you must be light. So the bars of the prison are layered. Distance that dilates purpose, gravity that demands impossible speeds, energy costs that explode with ambition, and a medium that fights every attempt to skim through it. Which is why the Milky Way is not just where we live, it's what we belong to, a gravitational citizenship we cannot easily renounce. And yet, there is a crueler truth waiting past the rim, a boundary that mocks even the idea of escape. Because beyond the edge of our galaxy lies not open water, but a current running the other way. A universe that expands, pulling distant shores faster and faster until they slip beyond reach, meaning that even if we beat the galaxy, we still lose to the cosmos itself. The speed of light sounds like a finish line, an ultimate number etched into the fabric of reality. Yet when the dream is leaving the Milky Way, even light itself feels slow, because across galactic distances, a beam is not a bullet but a glacier, and time becomes the enemy that never tires. The nearest large galaxy, Andromeda, sits 2, The speed of light sounds like a finish line, an ultimate number etched into the fabric of reality. Yet when the dream is leaving the Milky Way, even light itself feels slow, because across galactic distances, a beam is not a bullet but a glacier, and time becomes the enemy that never tires. The nearest large galaxy, Andromeda, sits 2. Now picture the speeds that people propose for interstellar travel. 1% of light, maybe 10 in the far future, ambitious, intoxicating numbers, and then run the math. Because 1% of light is still 3,000 kilometers per second, and at that pace the nearest star beyond the Sun is decades away, while the other side of the galaxy remains 10 million years distant, a travel time so large it stops feeling like a journey and starts feeling like geology. Even if a starship could accelerate at a comfortable 1G, flip midway, and decelerate, classic science fiction elegance, the energy demands soar like a cliff, since kinetic energy scales with V2V2, and halving the travel time means quadrupling the energy, while doubling the ship's mass doubles the bill again, turning propulsion into a bottomless tab. There's a deeper twist in the knife. Going fast isn't just about propulsion, it's about survival, because the interstellar medium that looks empty on paper becomes a minefield at high speed. A single dust grain, a fleck no bigger than sand, striking at a meaningful fraction of cc carries explosive energy, a micro-detonation against your hull, and the faster you go, the worse it gets. So the solution is armor and shielding, and armor and shielding make you heavier, and being heavier makes you slower or vastly more energy hungry, which loops you back into the same trap with higher stakes. Engineers call it a trade-off. In practice, it behaves like a law of nature. Light, for all its purity, cannot rescue us from the arithmetic. The galaxy is too wide, the energy curve's too steep, the hazard's too cumulative, so just go faster collapses into a paradox. To move quickly enough to matter, you must carry energy and protection on a scale that stops you from moving quickly enough to matter, and even if a civilization finds a narrow corridor of possibility, laser sails, fusion pulses, antimatter feeds, the path only threads the stars of our own island, because the leap from interstellar to intergalactic is not a bigger step, it's a different kind of wall, which begs the question that will drive everything that follows. If speed and time betray us within our own galaxy, what happens when we try to outrun the galaxy itself and crash into the final boundary that doesn't care how clever we are? Gravity on a galactic scale and a universe that is expanding beneath our feet. Gravity sounds gentle, an invisible whisper that keeps moons in line and planets faithful. Yet on the scale of a galaxy, it becomes a cliff face, a sheer wall of energy you must climb to leave home. Because the Milky Way isn't just stars and glow, it's a gravitational well with edges higher than our engines can dream to crest. Imagine a bowl so wide you mistake it for flat ground, then try to run to its rim while the ground subtly tilts against you the whole way. This is what it means to live inside a galaxy, where motion feels free but every path is secretly curved, every orbit a concession to a pull that never sleeps. Our sun moves at hundreds of kilometers per second around the galactic center, a quiet testimony to how deep the bowl is, how fast you must be just to stay in the dance without falling inward. Escape means more than fast. It means faster than the fastest thing you already are, because you're not starting from rest. You're starting from a moving carousel that refuses to let go. Locally, near the Sun, the escape speed from the Milky Way is measured in the brutal neighborhood of hundreds of kilometers per second. Not a tidy rocket equation problem, but a continental divide of energy, where every increment of velocity demands a feast of power, and the bill doubles again when you remember you must also slow down somewhere else if you intend to arrive in one piece. Earth's 11 kilometers per second feels like a sprint. The Sun's grip at our orbit, roughly 50 times harsher, feels like a marathon. The galaxy's wall is the mountain beyond the horizon, the one you only recognize after hiking all day and realizing the peak was a full summit. There is a cruel arithmetic here. To push a significant mass, habitat, life support, shielding toward escape speeds, the kinetic energy requirement explodes, scaling with the square of velocity, which means getting halfway to the number is hard, getting most of the way is punishing, and closing the final gap becomes a kind of financial singularity, where energy, infrastructure, and time all collapse into not today. And this is before paying the tax of efficiency losses, waste heat you must radiate into cold space, and the protective mass you need to survive decades of high-speed grit colliding with your hull. Every practical fix adds kilograms, and every kilogram makes the energy canyon deeper. The wall grows as you approach it. Some will point to shortcuts, slingshots off massive bodies, surfing gravity like a thief of momentum, and slingshots do wonders inside a solar system, where a planet's orbital energy can be borrowed. But to rob a galaxy, you must flirt with its central giant, the black hole whose neighbourhood is less a highway and more a demolition derby, where a mistake isn't a delay, it's spaghettification. Yes, nature makes escapees, hypervelocity stars flung by deadly billiards near the core streaking out at thousands of kilometres per second. But take the hint embedded in their origin story. Leaving the galaxy is not a matter of clever engineering so much as catastrophic dynamics, the kind that breaks more things than it liberates. Even if a starship could thread some exquisite path, assembling velocity from a chain of precision maneuvers, the prize at the end isn't freedom in the romantic sense. It's the outskirts, the halo, a sparse realm where the galaxy's pull thins but doesn't vanish, where dark matter's unseen hand still tugs, where every additional meter per second you need must be paid in full. Out there the stars grow fewer, the night grows blacker, and the sense of leaving feels less like crossing a border and more like suffocating the signal of home until it fades beneath the noise. Crossing the official boundary is a technicality. The struggle is the tab you had to pay to get there, and the tab that keeps accruing as long as you keep moving. Here is the sting. A galaxy doesn't hold you the way a planet does, with a clear horizon and a clean burn to freedom. It holds you with a geometry of motion, with orbits that pretend to be liberty, with speeds that feel heroic and yet never quite enough, turning escape into a problem that looks solvable from far away and becomes a mirage up close. The more you accelerate, the more the problem reveals hidden terms in fine print, until you discover that out is not just a direction, it's a budget you cannot close. And beyond this wall of gravity, beyond the energy cliffs and the dwindling stars, something larger is waiting, something no slingshot can bargain with and no reactor can outspend. A universe in motion, space itself stretching between islands of light, carrying most of them away faster than any engine can pursue. The universe is not a still ocean, it's a tide that pulls the shores apart. So when we talk about leaving the Milky Way, we're not just fighting gravity, we're racing an expanding fabric that quietly steals destinations from under our feet. Space itself stretches, not like a wind you can lean into, but like a metric changing the distance after you've already measured it, which means you can aim perfectly and still fall behind, because the target is receding not through motion, but by the growth of the in-between. This is the first betrayal. You can sail forever and never catch the horizon if the sea keeps growing faster than your ship can cut through. On local scales, between nearby galaxies bound by shared gravity, the expansion can be ignored, the same way you ignore the Earth's spin while running down a street. But step beyond our little cluster and the rules flip, because there the expansion wins, and it doesn't negotiate. There exists a cosmic speed limit everyone knows, the speed of light, and then, wrapped around it, an even colder truth. There are places receding from us faster than light, because space itself is doing the moving, and no engine, no matter how perfect, can cross a distance that grows faster than it can be closed. This isn't a loophole, it's the lock. Think in horizons, not maps. There's a sphere around every observer beyond which communication is not just difficult, it is impossible, because light from beyond that boundary will never arrive. Not now, not ever, not even if you wait until the last star burns out. Call it a cosmic event horizon and realize what it implies. Even perfect signals can fail, even perfect ships can chase forever and never arrive. It's not a failure of effort, it's the geometry of the universe saying no. Now fold that horizon back onto the dream of intergalactic travel. Suppose a civilization masters propulsion so completely it can cruise at a hefty fraction of light speed, threading the hazards and paying the energy bill with the patience of ages. Impressive, astonishing, heroic. And yet most galaxies are not merely far, they are being carried away by the expansion so strongly that the gap grows faster than any craft can reduce it. There is a narrowing window of reachable islands, a dwindling archipelago of light we can, in principle, still touch. Beyond that, the night is not just dark, it is sealed. The tragedy scales with time. As the universe ages, the reachable set shrinks, the cosmic web thins into isolated oases, and future astronomers, our distant heirs, will look up and see only the local stars, perhaps only our own galaxy and its merged companions, and they will argue about whether other galaxies ever existed because their evidence will have redshifted into silence. The cosmos becomes a smaller story the longer it runs, not because it is contracting, but because its parts are moving beyond the possibility of conversation. Leaving the Milky Way, then, is not like crossing an ocean to a new continent. It's like rowing against a river that strengthens with distance, until the current outruns your oars, your engine, your hope. The invisible wall is not made of matter or metal. It is made of expansion itself, a boundary that doesn't stand in front of you so much as recede as you approach, forever keeping you on the near side. And yet this is only the outer moat. Inside the walls of our own galaxy, another jailer is waiting, one that doesn't push us away but holds us tight. Dark matter, the unseen mass that deepens the well we must climb, tightening the Milky Way's grip with a hand we cannot see and cannot bargain with. Dark matter is the quiet warden of our galaxy. No light, no colour, no shimmer, just mass in the places that matter, deepening the well we live inside and tightening the grip we try to forget. Picture the Milky Way as a bright disk floating in a larger invisible sphere. The disk is what we see. The sphere is what holds us, a halo of unseen matter that outweighs the stars and gas several times over, extending far beyond the shining spiral we photograph in textbooks. The stars sketch the shape of home, but the halo writes the rules of motion, and the rule that breaks our dream is simple. The deeper the well, the higher the price of escape. This is why the numbers hurt. The local escape speed isn't just the sum of starlight and gas. It's set by the total gravitational potential around us, which means the invisible dominates the invoice, dictating that hundreds of kilometers per second are the bare minimum to climb out, and any uncertainty in the halo's mass profile only moves the bar within a range that still ruins propulsion plans. Change the shape of the halo from cusped to chord, tweak the density slope, argue about models, it doesn't turn the mountain into a hill, it just shifts which side is steepest. The conclusion doesn't blink. Dark matter is the reason the galaxy's hand is heavier than it looks. The halo's reach is psychological as much as physical. Travel outward and the stars thin, the gas thins, the disk fades, yet the pull persists, because the halo doesn't end where the light does, and so your ship keeps paying the tax even in darkness, climbing a bill that seems to follow you into the void. It tempts you to think you've almost made it. No stars, no glow, just silence, then reminds you that gravity doesn't need a backdrop to work, only mass, and the mass you cannot see is the mass that won't let you go. The border is not a line on a map, it's an asymptote of effort. If the Milky Way were made only of the matter we could see, the ledger would be brutal but not hopeless in imagination. With the halo in place, the ledger gains a surcharge on every line item, because escape velocity scales with the depth of the potential, and the potential is carved by invisible hands. Ask hypervelocity stars how they do it, and they'll answer with scars. They are flung by violence near the central black hole, not coaxed by engines, blasted past the threshold by catastrophic billiards that can afford the price because they never had to save for it. We build. The galaxy throws. Only one of those methods clears the bar. There's a darker irony here. The same halo that binds us is the quiet architect of everything we love about this place. Its spiral arms, its long-lived orbits, the calm suburb where life had time to learn fire and language. Because without that extra gravity smoothing rotation curves and shepherding the disk, our home would be a different, harsher story, and perhaps not the story that includes us at all. The warden is also the builder. The prison is also the city. The constraint is also the reason we had time to dream of leaving. The price of stability is permanence. So when people say, just go faster, the halo smiles, because faster isn't free, and the higher you climb, the more of it you still owe. The Milky Way's visible edge is not the end of its authority, and dark matter doesn't negotiate with cleverness, only with energy, delivered at a scale that turns starships into fantasies and fantasies into parables. Which leads to the next realization, colder than the halo and larger than the disk, that even if we could pay every kilometer per second demanded by gravity, the universe beyond is slipping away on rails we cannot touch, redshifting into silence while we count our fuel and watch the numbers go the wrong way. The dream fix arrives with a flourish. Bend space, don't cross it. Because if distance is the enemy, why not edit the map? Fold the paper so two faraway points touch, then step across the crease and call it travel. It sounds like a jailbreak written into the code of the universe itself, and in equations there are solutions that look like doors, wormholes that bridge remote regions, warp metrics that carry a bubble of space like a boat on a wave. The metaphors are intoxicating. Shortcuts, tunnels, surfing the fabric rather than fighting it, and for a moment the Milky Way's walls feel optional, like a rule that cleverness can finesse. Then the bill arrives. A traversable wormhole isn't just a hole, it is a precisely engineered throat of geometry that refuses to stay open without something that behaves like negative energy. An exotic pressure that resists collapse, the opposite of anything found in the fuel tanks of reality as we know it. Warp drives, in their most famous forms, ask for similar strangeness. Energy densities that would crush planets into cinders if ever misapplied, and even when scaled down to thought experiment levels, they demand stresses and field configurations that push known physics to a breaking point. The math permits the shapes, the universe withholds the materials. Even if a civilization could conjure the exotic, tame quantum fields into negative energy, stabilize a wormhole throat wider than a particle, there is the problem of engineering a gateway that doesn't magnetize every disaster in the neighborhood. A hole in space-time is not passive. It couples to everything: radiation, fields, fluctuations. A single stray burst can amplify inside the geometry and slam the door, or turn your doorway into a death ray with perfect aim. Stability is not a design spec. It's a perpetual fight against the universe's tendency to ring like a bell and then shatter. Warp concepts carry their own thorns. A bubble that moves faster than light relative to distant space still drags a bow wave of high-energy particles and fields, a pile-up at the front and a wake at the back, so that when the bubble stops, the stored fury may discharge into the destination like a cosmic shotgun. Worse, causality problems lurk at the edges. Slip the constraints just right, and time-like loops appear, inviting paradoxes that physics protects itself against with the bluntest of tools, by making the required conditions unreachable. The universe is tolerant of imagination, it is strict with chronology, and beneath the spectacle sits a quieter veto. The energy scales implied by even modest spacetime manipulation are monstrous on human terms, rivaling outputs of stars, not reactors, and that's before paying for precision, control, and error correction in a medium, spacetime, that offers no testbeds smaller than everything. If you can barely keep a fusion plasma in a magnetic bottle without it writhing free like a living thing, what hope is there to bottle geometry itself and ask it to behave for years? The analogy isn't perfect, but the lesson rhymes. Nature lets you try, then charges interest on every decimal of control. So the illusion of travel is not that these ideas are nonsense. They are mathematically literate, sometimes even elegant. It's that they move the problem from propulsion to ontology, trading rockets for requirements that sit beyond the frontier of verified physics. You don't escape the walls of the Milky Way by wishing space was softer. You discover that space is harder than it looks, a medium that can be described with grace and still refuse to be sculpted at scale. And yet the human reflex persists. If space won't bend for us, perhaps energy will. So the next gambit is brutal in its honesty. Don't cheat the distance, overpower it. Build engines that pour out momentum like a river, harvest entire worlds for propellant, and see whether sheer power can turn the impossible into merely expensive. Power can move mountains, so we imagine it can move galaxies. Yet when the target is escape, the ledger turns brutal, because to make a starship truly fast, you don't just add energy, you square it, feeding the kinetic bill that grows with V2, and then you double it again if you plan to slow down at the end. Chemical rockets are poetry for planets and dead ends for stars. Fusion is a better verse, fission a footnote, antimatter a promise written in platinum ink with no bank to cash it, and photon drives the purest but most punishing of all, demanding power flows that read like stellar budgets rather than engineering specs. Simple anchors make the point. Accelerate a single ton to a tenth. The speed of light and the lower bound just for kinetic energy is on the order of 1017 joules, hundreds of petajoules, before you talk about inefficiencies, heat rejection, or deceleration, and shifting to human-scale payloads multiplies this into figures that rival national grids, not mission budgets. Laser-push sails look elegant because they keep the ship light, but they only outsource the pain. Building arrays that deliver multi-gigawatt to terawatt beams for sustained periods is a civilizational project, not a lab demo, and even gram-scale probes at 0.2c imply power and precision that brush against the practical limits of optics, materials, and money. Fusion sits in the tempting middle, energy-dense exhaust speeds of a few percent of light, plausible in principle, and still the arithmetic snarls, because thrust to weight is stingy, burn-up fractions are modest, and the waste heat won't politely disappear into a radiator that remains small and light while running at thousands of Kelvin for years. The radiator grows, the ship slows, and the spiral tightens. Photon rockets are the endgame of patience, converting energy straight into momentum but want power-to-mass ratios that make star cores look casual. So while they dodge the tyranny of propellant, they accept the tyranny of power, and it is merciless. Beam the energy from home, say the optimists, and the problem moves from propellant tanks to infrastructure, where the mirrors must be near perfect, the pointing flawless across astronomical distances, and the sail materials reflect nearly everything while surviving a bath of light that would cook planets. Improvements exist, clever optics help, but the target keeps sliding just out of reach, as if the universe enforces a sliding tax on every new decimal place of performance. Meanwhile, every extra 9 of reliability and precision costs not linearly, but exponentially, because systems at this scale couple to everything: vibrations, dust, solar wind, politics. The rocket equation was only the first boss fight. The power equation is the raid boss waiting in the next room. Call this the technological mirage. The nearer you get, the further it seems, not because ideas are wrong, but because the last 10% of capability costs 100 times more than the first 90, and interstellar ambitions demand not 90% but everything. Even assuming mastery, the prize is parochial. You cross between stars of our own island with difficulty measured in centuries and fortunes, while the intergalactic jump remains orders of magnitude beyond, an energy cliff that turns starship dreams into garden paths. Which brings the story back to time, the currency that bleeds while power schemes mature. If energy won't stretch enough and space won't bend enough, the only thing left to flex is patience, lifetimes stacked into generations, and that opens the door to a human problem no engine can solve: how to keep meaning alive on journeys that feel less like travel and more like inheritance. Time is the currency we cannot counterfeit. So when engines run out of miracles, missions try to buy years with patience, and patience with generations, turning travel into heritage and arrival into legend carried by descendants who never agreed to leave. Picture a vessel the size of a city drifting through dark seasons that last centuries, gardens under artificial suns, rivers that loop forever, a quiet weather of recycled air, where birthdays mark not progress across space, but the maintenance cycles of reactors and farms, and the children learn navigation alongside language because their whole world is a trajectory. Purpose must be taught like math. Meaning must be inherited like a surname. The math of the journey is merciless and simple. At 1% of light speed, the nearest stars are decades away, which is survivable if you treat life like a marathon with a finish line. At the scale of the galaxy, the travel times grow into millions of years, beyond any single lifetime, beyond any dynasty. And so the vehicle becomes a culture, the itinerary becomes a history, and the mission becomes a civilization with its own weather of beliefs. The ship is no longer a craft, it's a continent. It's people citizens of motion rather than passengers on a trip. And with that shift comes the oldest human problem in a new costume: how to keep a story alive when no one living will see its ending. Rules help. Charters, rituals, founding myths that anchor behavior when original context fades. But time gnaws at all scaffolds, and even perfect systems must contend with drift. Priorities shift, factions harden, maintenance is postponed just once, and entropy sneaks in through the smallest hatch. Resource cycles demand vigilance at the scale of centuries: hydroponics, nutrient loops, closed ecologies that never get a day off. So a brief era of apathy can cost a decade of recovery, and a decade lost can become a generation born into scarcity. The ship's most valuable cargo is not water or air or fuel. It's continuity, that fragile, invisible thread. Psychology becomes engineering. Isolation breeds myths and grievances. Monotony erodes attention. Minor conflicts inflate in a sealed world that cannot step outside to cool off. Sleep cycles drift. Seasons are artificial, and the night sky never changes. No constellations rising or setting, just a fixed dome of unsolved destination. So the brain, hungry for novelty and anchored by rhythms older than civilization, must be retrained to accept a life where progress is a number on a console rather than a sunrise over a new shore. Tools can help. rotating crews, art as oxygen, rituals that turn maintenance into ceremony. But tools are not magic, and every system of meaning needs renewal. Then there is the paradox of arrival. Any craft that survives centuries will do so by becoming conservative, not in politics but in metabolism, minimizing risk, smoothing variance, avoiding shocks, which means the culture best suited to finish the voyage is the one least suited to sudden change when the destination finally arrives. After generations of optimizing for keep going, a planet looms, an atmosphere waits, gravity calls, and the ship must pivot to land now, explore now, risk now. The moment of triumph is also the moment of maximum stress, because nothing inside a closed system prepares you for the chaos of open worlds. Most dangerous of all is the quiet success, functioning exactly as designed. A mission that runs well for centuries becomes indistinguishable from a society that exists for itself, and at that point the destination becomes optional, a rumour from the prologue. The children of the children might choose to turn aside to orbit a brown dwarf for 3 more lifetimes of safety, to become archivists of a journey rather than authors of a landing. It's not failure, it's evolution under constraint. A ship can reach a star and still miss the point, because the point was never a coordinate, it was continuity under time. This is why time is the deadliest barrier. It doesn't break ships, it dissolves reasons. Engines can be repaired, hulls can be patched, but belief, passed through 1,000 careful hands, frays with each exchange unless tended like a flame. And if that's the challenge just across the local neighbourhood, imagine extending that patience to the edge of the Milky Way, then beyond, where the calendar outgrows language and purpose must be as renewable as air. There's a horizon inside the galaxy that isn't a line on a star map, it's a limit in the mind. Because once a journey stretches past a human life, leadership becomes inheritance and motivation becomes a resource that must be farmed, stored, and renewed like air or water. Long-duration spaceflight on the small scale already shows the fault lines. Isolation gnaws, circadian rhythms drift without natural dawns and dusks, cognition bends under stress, and mood disorders shadow the edges of routine, reminders that biology evolved for Earth's cycles and fights when those cycles are erased. The space environment amplifies everything. Microgravity rewires the body and the brain, shifting fluids, altering sensory integration, changing visuospatial performance, and demanding constant countermeasures just to keep crews baseline capable for months. Scale that to decades, and the countermeasure becomes culture, not just treadmills and tablets, but rituals, roles, and meaning architectures that keep minds aligned with tasks that repeat without visible landmarks. Radiation adds another layer, not only to cancer risk and vascular health, but to the central nervous system itself, where galactic cosmic rays can nudge cognition, mood, and neuroplasticity, subtle degradations that don't announce themselves on any single day yet compound across years unless shielded, monitored, and treated with the kind of vigilance usually reserved for reactor cores. History and analogues whisper consistent lessons. Crews in confinement face interpersonal friction that scales with time, monotony that erodes attention, and stress that sneaks past training to reshape behaviour. Countered by deliberate habitability design, structured autonomy, and mental health protocols that treat positive effect and purpose as mission-critical consumables, not luxuries to be rationed after work is done. The engineering answer is systems thinking applied to psychology. Build habitats that choreograph light, sound, and privacy. Schedule work-rest cycles that respect cognitive limits. Embed rotation of duties to prevent skill atrophy and burnout, and institutionalize reflection, councils, art, ceremony, so that identity keeps pace with routine, because without identity, routine curdles into resentment and drift. Even with all of that, time remains undefeated. The longer the mission, the more a ship becomes a society, and societies evolve goals, sometimes away from the launch manifesto, so governance must be adaptable without becoming fickle, principled without becoming brittle, a living constitution that can absorb shocks without losing the through line that justifies continued motion. That through line cannot be a slogan. It must be a practice repeated until it becomes muscle memory, which returns the story to the galaxy itself. Because if this is the price merely to stitch a few stars together, then the idea of stitching an entire galaxy, let alone leaping beyond its rim, demands a patience that exceeds biology and a continuity that exceeds culture, leaving one conclusion waiting like a quiet verdict. Some horizons will not yield to courage alone, and recognizing that boundary is not surrender. It is how wonder stays honest enough to last. Maps of the universe feel like promises, threads of light connecting island to island. Yet those threads are stretched on a loom that won't stand still, because as distances grow, wavelengths grow with them, and the colours of distant galaxies slide downward into red, then into infrared, then into radio, and finally into silence where detectors have nothing left to catch. Redshift is not just a measurement, it's a vanishing act, taking the ancient light of faraway realms and pulling it beyond the reach of our eyes and instruments, so that the farther you look, the thinner the story becomes, until the page itself seems to fade. This isn't poetry. It's the universe's expansion turning observation into archaeology with missing bones. There's a practical cruelty here. Telescopes fight extinction with bigger mirrors and colder sensors, collecting photons that took billions of years to arrive. Yet no amount of cleverness retrieves light that never gets here, because space can stretch faster than your curiosity, and when that happens, information is not just delayed, it is denied. The signal weakens by the square of distance, then again by the redshift stretching each photon's energy thinner, until even perfect instruments stare into a field that looks empty for reasons that are not technological at all. You can pour money into mirrors and still lose to math. In the deep future, this quiet theft becomes a lockdown. The cosmic web frays into isolated neighbourhoods, bound clusters that remain, and everything else that slips away, so that observers born trillions of years from now will live in a sky that lies by omission, a dome of local stars with no hint of a larger web, no microwave background to whisper of a hot beginning, no external galaxies to betray the map. Cosmology will shrink from measurement to myth, not because curiosity fails, but because evidence leaves. The laboratory remains, the archive erases itself. Even now, there are edges to what can be known in principle. Beyond certain horizons, light is on an endless treadmill, running but never arriving, and messages sent outward face the same fate, swallowed not by darkness, but by growth, as if the universe prefers each island of gravity to mind its own business. Communication, travel, verification, all of it inherits this boundary, turning our best questions into soliloquies. You can ask the night for answers, and the night can be honest, and still you will not hear back. This is the shape of our predicament. To leave the Milky Way is to try to outrun both gravity and history, and while engines might bruise the first, the second simply waits, red-shifting the rest of creation into a quiet that feels like sleep, which leaves a colder calculus on the table. If the outward path dissolves with time, perhaps survival means turning inward, building deeper roots within the island we have, because the ocean is not a highway, it is entropy with a current. Gravity isn't just a tug downward, it's a landscape we live inside. So when people say, escape the Milky Way, they often imagine a cliff you can climb with enough fuel, when in truth it's a continent-wide slope with no edges, a smooth, relentless decline toward the centre that turns every step outward into a fight against the shape of space itself. Stand in your mind at the sun's position and look up out of the disk. There's no wall, no gate, just thinner stars and quieter gas. And yet the cost of each additional kilometre per second climbs like compound interest. Because what binds us is not a single mass, but the integrated pull of 100 billion stars stitched to a vast invisible halo. The galaxy isn't a fortress with battlements. It's a valley carved so shallow and so wide that you forget you're walking uphill until you've run out of breath. Escape velocity makes this plain. From Earth, 11 kilometers per second buys you a ticket to the open sky. From the sun's gravity at Earth's orbit, hundreds of kilometers per second are the going rate. From the Milky Way's local well, the bill rises again into the high hundreds, depending on the neighbourhood and the mass profile you assume. These aren't numbers you throw a better fuel at. They're thresholds that force a change in kind, not degree. Chemical energy folds first, then nuclear fission bows, fusion narrows the gap and still leaves most of the mountain unscaled, and photon propulsion turns the last steps into raw power economics that look more like stellar engineering than spaceship design. The higher you climb, the more expensive each meter per second becomes, not because of a conspiracy of engineering, but because kinetic energy grows with the square of speed, and your radiator area does not care about your dreams. What makes the Milky Way's well feel like a cliff is the way it follows you. Move outward, and the stars thin. The disk fades, but the pull lingers, a soft insistence from an extended halo that does not end where the light ends. There is no clean border to cross and throw your hat into the air. There is instead a long drag through a region where progress looks like stillness, because the nearest points of reference recede too slowly to register across lifetimes. Navigation becomes faith in instruments. Motivation becomes faith in purpose. Out there, a ship can bleed propellant and patience without any visual proof that the exit is nearer. Sailors once spoke of the horse latitudes, where ships stalled in windless seas and crews lost their nerve. The galactic analogue is a domain of sparse matter and long-time constants, where your engines must carry not just mass but morale. Every kilogram of shielding against dust impacts, which at a fraction of light speed strike like grenades, demands more thrust, and every watt of waste heat you must reject demands bigger radiators, which add area for particles to hit, which demands more shielding again. The loop is vicious, a treadmill of trade-offs that punishes momentum with mass and punishes mass with more momentum. What looks like a straight sprint up a hill turns, on contact, into logistics against an enemy that refuses to shoot back because it doesn't need to. There's a subtler cruelty in the local terrain. We're not sitting on a stationary platform. We're already moving at hundreds of kilometers per second around the galactic center, and that motion is a vector with a direction, not a store credit you can spend anywhere. If your intended escape route doesn't align with the motion you already have, you must pay to rotate that velocity, not just add to it. In orbital mechanics, changing direction is often costlier than changing speed, and at galactic scales, reorienting a fast, massive system is like turning a river with a spoon. You can leverage gravity assists around stars, yes, but inside the disk their wells are shallow compared to the energy you need, and the only slingshot with fangs sits at the center, where passes that grant real speed also roll dice with tides that do not forgive mistakes. Nature gets a few lucky shots, hypervelocity stars flung out like sparks from an anvil. But those are accidents of violence, not blueprints for travel. Even if a ship clears the local escape threshold, a triumph that implies engineering beyond anything our species has realized, the victory is strangely anticlimactic. The view does not switch scenes. There is no skyline to celebrate. What changes first is the bookkeeping. The potential energy term stops being negative with respect to the galaxy, the asymptote flattens, and your engines, if they're still warm, can finally buy not just less curvature but more distance per unit of patience. The second change is psychological. The stars around you no longer share a single coherent rotation. Their motions become a background of drifting lights, and your trajectory ceases to be a chapter in the Milky Way story, and becomes a straight line across a page with fewer words on it. The romance of leaving collides with the reality of being between, and that is the heart of the Gravity Wells lesson. Escape is not a moment. It is a budget extended across decades or centuries, a composite of thousands of solved mundane problems that each punish sloppiness with exponential cost later. You don't beat the well with a flourish. You erode it with relentless competence, and that is a harder sell to the human appetite for drama than any cinematic burn toward freedom. We want a cliff we can leap. The galaxy gives us a slope that never ends, which is why, when people say, "we will never leave the Milky Way," they are not cursing ambition. They are describing topology and time. The well is broad, the fuel is finite, the hazards scale with speed, and the fastest paths run too close to monsters to be civilized routes. Even if we thread all of this, brute force, patience, precision, the prize beyond is not a promised land but a deeper quiet, where the distances grow into numbers that stop feeling like travel and start feeling like geologic eras written in vacuum. And beyond that quiet, there is another verdict entirely, one that gravity does not control and engines cannot bribe. A universe whose fabric is lengthening under our feet, turning the far shore from a destination into a receding idea. Dark matter writes the outline of our galaxy, but at the center, a different author carves in bold because every orbit, every swirl of gas, every long arc the stars trace is anchored by a silent weight. 4 million suns heavy, a supermassive black hole that doesn't need to roar to rule. Call it the anchor, the metronome, the slow heartbeat of the Milky Way, a gravity well within the well, so deep that time and light both bend in deference, and so central that it shapes the dance of everything else without ever needing to move. We imagine escape as a straight line outward. The galaxy reminds us that the road wraps around a monster we cannot ignore. Near that core, the rules intensify. Gravity isn't a gentle gradient. It's a steep gorge where stars whip around like sparks off a grinder, completing orbits in mere years instead of centuries, their paths mapped like handwriting on curved paper. This is where hypervelocity stars are minted, where a close brush between a binary and the black hole can tear one star free and sling the other out like a bullet, acceleration by catastrophe that proves a bitter point. Yes, you can leave the galaxy, but the price of the ticket is a gravitational near-death experience no starship could survive by design. Nature accomplishes with violence what engineering cannot achieve with caution, and that should sober any dream of harnessed slingshots at the centre. The core is not just a place, it's a pressure cooker for matter. Gas clouds tumble inward and shear into filaments. Magnetic fields twist into knots. Shocks heat the infalling material until it radiates across the spectrum. And yet, compared to the active hearts of some galaxies, ours is quiet, a sleeping giant that only murmurs. That quiet is a gift to life in the suburbs, fewer sterilizing flares, fewer cosmic tantrums, and a curse to our ambitions, because the very calm that sheltered our evolution denies us the dramatic energy flows a civilization might fantasize about tapping. The Milky Way provides stability, not shortcuts, safety, not exits. There's an exquisite irony in how the core governs the outskirts. The black hole's direct gravitational pull only dominates very near the centre, but its presence, fused with the mass of the surrounding bulge and the dark halo, defines the potential landscape that sets the terms for every orbit out here, including our own. It is the punctuation mark at the end of the galactic sentence, a period that makes the grammar of motion unambiguous. Escape velocity is not a random number. It is a property of this entire structure. From the thin disk we can see to the invisible halo we can't, all rooted in a nucleus that never has to announce itself to be obeyed. For a starship builder, the core reads like a false promise. The mind conjures trajectories that dive toward the centre to steal speed, the way probes skim Jupiter to cheat gravity's accounting. But planetary assists work because you tap a moving body's orbital energy, and the central black hole isn't an engine you can borrow from without risking annihilation. The region where its pull is meaningful is also the region where tidal forces shred, where radiation can spike, where a miscalculation becomes a headline written in X-rays. Even if navigation were perfect, the environment is not. Dust, gas, and charged particles fill trajectories with hazards that scale with velocity, turning theoretical gains into practical gambles. Worse, any path that leans on the core abandons the premise of a controlled, crew-safe expedition. Hypervelocity stars earn their speeds by being torn from companions or flung by chaotic three-body encounters, events with no brakes, no steering, no second chances. That is not a maneuver. It's a coin flip with railguns. Starships need margins, not miracles, and margins evaporate near the maw. The very object that demonstrates the galaxy's capacity to throw something out is the place least compatible with the survival of anything designed to carry meaning, memory, or life. Step back, and the message clarifies. The galactic core is the keeper of coherence. It anchors the rotation curve, shapes the bulge, helps hold the disk together with the aid of the halo, and in doing so creates the conditions for long, stable eras where star systems can quietly orbit, and planets can dare chemistry's slow ambitions. The same architecture that made a home for us also locks the doors behind us. Our existence and our confinement are two sides of one design. If we dream of leaving the Milky Way, we are dreaming of escaping the very order that allowed us to dream at all. So the monster that anchors us is not merely an obstacle, it's a revelation about how galaxies work, about how gravity can be both cradle and cage, about how scale turns familiar words, escape, speed, distance, into different animals. We can celebrate the ingenuity that teases sails with lasers, coaxes fusion into impulses, or cools sensors to catch photons from the dawn of time, and we should. But when we aim those triumphs at the edge of the Milky Way, the core answers with a quiet, unblinking truth. This structure holds. The orbits here are not accidents, they are commitments, and beyond that commitment waits the larger verdict the universe writes in redshift and silence. Even if a civilization solved propulsion, shielding, patience, culture, even if it learned to climb the well without stumbling, the sea past the reef is not a highway but a current running outward, scattering islands into isolation, which leaves a different kind of project for beings like us. To learn the full grammar of this galaxy we cannot leave, to map it not as a prison but as a continent, and in doing so to turn acceptance into mastery, and mastery into wonder that doesn't need departure to feel infinite. Step beyond the bright rim of the Milky Way in your mind and the scene doesn't become a fireworks show. It becomes a hush, a gulf so thin and so empty that emptiness itself starts to feel like a substance, a pressureless ocean where a handful of atoms drift in a space the size of a room, and dust grains are rare enough to be stories. The intergalactic void is not a road. It is a silence between choirs, vast, cold, and indifferent, where even light, the one thing that moves without fatigue, stretches thin as it runs. Out here, distance stops being a number and starts being a mood. The scale is not hostile. It is worse. It is uninterested. Inside a galaxy, even the darkness lives. Fields twist, gas flows, stars shepherd each other's orbits. But outside, structure surrenders to smoothness. The nearest beacons are other galaxies, and they are not neighbours in any sense a human heart can use. They are lanterns hung on mountains a million horizons away. Signal becomes strategy. A single message sent across this gulf must be bright enough to be seen, against cosmic background noise, and narrow enough to land on a receiver that exists as a pinpoint in a sky without grid lines. Miss by a hair and you miss forever. The void forgives nothing because it remembers nothing. A ship that aims for such a crossing must carry its entire ecosystem as an argument against entropy. Water doesn't cycle by itself. Nutrients don't magically reappear where they were used. Microbes evolve in the corners of pipes and decide their own agendas. Systems that are perfect for a year reveal flaws in 5, and flaws that are gentle in 5 become insurmountable in 50. Every loop, air, water, food, waste, heat, must be balanced without spillover and without surprises. And yet surprise is the default mode of complex systems. The longer you run, the more you find out what you didn't know you needed to know. Then there is the radiation weather, a slow snow of high-energy particles that never becomes a storm and never stops falling, a background hazard that chips at molecules and memories alike. Shields help but add mass. Fields help but demand power. Redundancy helps but multiplies failure modes in the long tail. The void, being nearly empty, feels safe. No rocks, no storms, no gravity wells. But its safety is the safety of neglect. It will not attack you. It will wait you out. Time is its weapon and patience its method, and both are inexhaustible. Navigation becomes philosophy. In a medium, this featureless inertial frames are all you own, and the stars you started with, faint as they were, shift too slowly to guide a life, let alone a lineage. Dead reckoning becomes live meaning. You maintain course not because the map says so, but because the mission requires it to be true, and so the map must be made from the mission. It's a trick humans have used before. Cathedrals built over centuries by hands that never saw the spire. But even cathedrals had towns around them, markets and seasons, a tapestry of feedbacks that kept will from evaporating. A ship in the void has only itself. Even victory tastes strange out here. Suppose a craft threaded every needle, shielding, supplies, governance, patience, and arrived at the outskirts of another galaxy after an epoch of motion. Arrival is not a harbour, it is another well, deeper than any planet's, guarded by the same trade-offs you left behind. Dust that bites at speed, gravity that sets prices in kilometers per second, energies that multiply like echoing debts. The intergalactic gulf does not deliver you to a new era. It delivers you to another version of the same argument, written in a different handwriting. You have crossed silence to reach a chorus that sings a familiar song about mass, momentum, and the exhaustion of ambition. But the harshest truth of the void is abstract. It has no leverage points. Inside a galaxy, you can borrow momentum from planets, harvest light from stars, anchor industry in orbits where resources flow. Between galaxies, the ledger has only entries on your side. There are no ports to resupply, no gravity to steal, no infrastructures to graft onto. The emptiness is honest accounting, and honest accounting is a villain to romance. Every useful thing you bring must be paid for up front, and the receipt is time-stamped in generations. Any optimism worth anything must be audited by that reality and still decide to act. So what lies beyond the Milky Way's edge is not freedom, but a distillation of all constraints, distance without landmarks, time without mercy, physics without loopholes, and meaning without audience. The void is the purest statement the universe makes about cost. It strips away the usual crutches, nearby suns, convenient wells, busy neighbourhoods, and asks a simple question with a complicated invoice. How much will you spend to remain yourself when nothing around you cares if you succeed? If the answer is everything, you may proceed, and the void will nod, and then it will take its time reminding you that everything is still not enough. And yet, there's a countercurrent hidden in the bleakness, not a solution but a reframing. The void forces a pivot from conquest to comprehension. If leaving the Milky Way is functionally unreachable, then the act of knowing it fully becomes the audacity, turning inward not out of fear but out of ambition, deciding that mastery of one galaxy is an enterprise vast enough to measure a civilization's courage. That is not settling. It is choosing a canvas large enough to honour the limits without letting them define the art. The intergalactic dark remains, a horizon that recedes as you approach, but the light within the island deepens, and depth, in the end, is another kind of distance worth crossing. Imagine astronomy with the volume turned down, pixel by pixel, note by note, until what was once an orchestra of galaxies becomes a solo, then a whisper, then the steady hum of your own machinery, because the future does not simply arrive, it edits. The universe is expanding, and that expansion carries more than worlds apart. It carries evidence away, so what can be seen now will not always be seeable, and what can be measured now will not always be measurable. This is not a technological problem. It is the geometry of reality erasing its own clues over time, as if history itself were dissolving into the medium that held it. Start with the sky most of us take for granted, a dome scattered with galaxies. In the far future, that dome simplifies. The local group, the Milky Way, Andromeda, their companions, merges into a single sprawling galaxy, while most other galaxies slide past a horizon set not by distance, but by expansion. Their light stretches, reddens, dims, and finally disappears beyond detectability, not because telescopes failed, but because light never arrives. Inside that shrunken stage, astronomy loses its external references, and with them, a portion of its confidence. Cosmology becomes a detective story where the witnesses moved out of town. The cosmic microwave background, the afterglow of the hot beginning, fades into wavelengths too long to catch without instruments of impossible size, buried beneath local noise and foregrounds that swamp the signal. The map of primordial ripples becomes a rumour, the inflationary fingerprints a legend, the baryon acoustic peaks an anecdote in a textbook that future scholars will argue over, like theologians passing a lost gospel. This is not melodrama. It is what expansion does when given enough time. It turns open questions into closed rooms. Distances, once triangulated via standard candles and rulers, flatten into ambiguities. Without a rich zoo of outward galaxies to calibrate against, the ladders that now stitch near to far begin to wobble. Hubble's law becomes parochial. Redshift loses context, the link between brightness and distance phrase. In that narrowed sky, precision cosmology, the craft of chiseling parameters to the second decimal, gives way to local astrophysics, deep and intricate but unmoored from the grand frame. The universe does not vanish, the story gets smaller. Consider the curriculum of a future observatory. It will still study stars, planets, remnants, chemistry and clouds, the dances of clusters, the lives of black holes, all the rich local physics of a mature galaxy that took trillions of orbits to compose. But its cosmology will be reconstructed from within like a memory palace, reliant on relics that survived and models that cannot be verified by fresh light from outside. Even perfect instruments cannot manufacture photons that never arrive. The scientific method remains, its sample shrinks. There is a human cost to this thinning. Science is not just equations and instruments, it is also narrative, coherent arcs that make sense of facts, and narratives breathe better with horizons. A sky full of other galaxies invites comparisons, checks, tests of universality. A sky with only one big island tempts parochialism, makes coincidences look like laws, and encourages elegant theories that fit a single case too well. The remedy is discipline and humility, qualities as essential as mirrors and sensors but more fragile. Those must be cultivated like crops in poor soil. Even communication inherits the loss. If expansion carries distant civilizations past our horizon, dialogue becomes monologue, and the search for companions curls inward into archaeology within our merged galaxy. Techno-signatures from beyond would stretch into silence. Messages sent outward would never be answered. Are we alone? Becomes a question that history once allowed, and time later forbids, not because the answer changed, but because the line went dead. In such an era, meaning must be found without the expectation of reply, and yet there is power in recognizing the edit as it happens. Knowing that evidence is perishable makes the present a laboratory with unique privileges. This age can still see the background glow, still sample galaxies at many epochs, still test gravity on scales that later observers will only simulate. To measure now is to preserve a fossil record for minds that will inherit a smaller sky. The act of observing becomes an act of conservation, a way to bottle starlight for a winter that will last. Call this the quiet tragedy of the future astronomer. Not ignorance, but isolation. Not darkness, but a narrowing cone of knowable things. The remedy is not despair. It is stewardship, of data, of methods, of skepticism, of institutions that can carry trust across centuries. If the cosmos will one day look like a single city of stars in a dark plain, then the library must become a cathedral, and the cathedral must be tended as if it were an engine keeping meaning warm, which returns, finally, to the thesis that sounds harsh and turns out to be tender. We will never leave the Milky Way, not because we lack courage, but because the terms are written into distance, gravity, energy, expansion, and time. In that recognition is an invitation. If the outward road recedes, the inward road deepens. The galaxy is not a consolation prize, it is an entire civilization's worth of frontier, a continent of physics and history and life that no era will exhaust. The future's sky may be smaller, but the work can be larger, and ore, if tended, does not need horizons to grow. Heat death sounds theatrical, like a curtain falling on the cosmos, yet in practice it's a slow unspooling, a quiet drift toward uniformity, where differences that once did work are smoothed into sameness, and the engines of structure run down because there is no more gradient to grip. Stars live on contrasts, hot cores and cold space, dense fuel and thin surroundings, and galaxies live on motion, orbital energy and fresh gas. But the deep future offers neither in abundance. It offers dilution. It offers time so long that words like epoch and era become nicknames for numbers too large to taste. It offers a sky that keeps every promise of expansion and entropy, until all that remains is patience cooling into silence. Start closer to home and walk outward in time. The main sequence ends one star at a time as hydrogen is spent and fusion retreats. Red dwarfs sip slowly and outlast giants, but nothing burns forever, and the universe is not subsidizing new fuel. White dwarfs dim into black dwarfs that the present epoch doesn't even contain because it hasn't lived long enough yet to make one. Neutron stars and black holes wait like punctuation at the ends of stellar sentences, and over unimaginable stretches, gravity's mergers grind the punctuation marks into fewer, heavier symbols. What was varied becomes simple. What was lively becomes archival. In such a universe, galaxies change their jobs. They are no longer foundries. They are museums. Their star formation quenched, their gas heated and lost, their disks thickened by time and tides. Collisions still happen, but as the cosmic web thins and neighbouring systems slip beyond the horizon, the supply of fresh interactions dwindles. The great cities of light become their own suburbs, self-referential and slowly dimming. When a galaxy can no longer refresh itself with cold infall, it turns into a closed economy and closed economies, without injections of new gradients, trend toward austerity, then toward stillness. Black holes grow to dominate the ledger of mass, not by tyranny, but by accounting. They swallow, merge, ring like struck bells in gravitational waves, and then settle, cold, dark and nearly perfect in their refusal to leak information, except in the most miserly quantum whispers. Hawking radiation gives them an end date written in exponents, a schedule so leisurely that it feels like mythology, yet it is a schedule, and it testifies to the same direction of travel as everything else. Differences being evened out, reservoirs being drained, the inventory of useful contrast trending towards zero. Entropy is not merely disorder, it is the number of ways a system can arrange itself without changing its macroscopic story, and that number grows as energy spreads. In the young universe, low entropy was a gift. The tight, smooth initial conditions gave room for structure to blossom as gravity carved clumps from uniformity. In the old universe, High entropy is the inheritance, and it leaves little room for work. Work is what you do when there's a hill to roll a ball down or a temperature gap to bridge. Heat death is the absence of hills. The table is level and very large. The ball can rest anywhere, and everywhere is the same. For a civilization, this is not apocalypse, it's attrition. Engines become harder to feed because temperature differences are smaller. Computational substrates run into fundamental thermodynamic costs that can't be optimized away. And every scheme that depends on external gradients becomes an exercise in internal bookkeeping. You can be clever, harvest from black hole accretion while it lasts, squeeze the last work from molecular clouds before they disperse, choreograph Dyson-like infrastructures to sip starlight before the stars fade. But cleverness is a bridge, not a destination, and the far bank is flat. The longer you plan, the more your plans must include subtraction. Meaning in such an era pivots. If the measure of success is conquest of distance, then the future looks like a slow defeat. If the measure is depth, comprehension, preservation, refinement, then the future looks like a monastic project on a galactic scale, a commitment to keep the flame of complexity alive as the night grows even and indifferent. The impulse to leave becomes symbolic rather than literal, an urge to cross thresholds of understanding rather than thresholds of space, because the latter hardens against us while the former, though never easy, does not close. This is the harsh reality behind the claim that we will never leave the Milky Way. It isn't a verdict on ambition or a lack of imagination, it's a statement about arrows that point one way. Gravity on galactic scales sets the speed taxes, the interstellar medium sets the armor paradox, relativity sets the energy curve, expansion sets the horizons, and entropy sets the long weather of the cosmos in which all projects sail. Any one of these could be argued with in a hopeful mood. All of them together make a climate, and climates outlast moods. Yet there is a strange comfort embedded in that climate. If departure is denied, then presence becomes profound. The galaxy is not a prison in the cheap sense. It is a territory vast enough to earn a lifetime of lifetimes. Hundreds of billions of stars, millions of worlds that may bear weather and stories, relic streams of ancient mergers etched across the halo, a central engine that has slept and woken across ages, and a dark skeleton whose shape we're only beginning to infer. If the outward door stays closed, the rooms inside are still countless, and their doors are still ajar. So the heat-death future is not a doom to be fled, but a boundary to be understood, the largest of all context lines. It tells us what kinds of victories last and what kinds evaporate. It suggests a pivot from empire to stewardship, from speed to endurance, from expansion to depth. It does not make awe smaller, it makes awe more honest, anchored not in fantasies of unlimited power, but in the discipline of living well within the laws that make a universe possible at all. In that discipline, the Milky Way is not a cage, it's a covenant. The future loves mirages, technologies that glitter on the horizon and promise to turn no into not yet. So when the dream is to leave the Milky Way, the mind summons masterpieces. Dyson swarms drinking starlight like oceans, antimatter factories bottling thunder, fusion engines pulsing with stellar hearts, warp rings sculpting space into shortcuts, wormholes held open by negative pressure like glass blown from the vacuum itself. Each vision is precise enough to feel inevitable, engineering blueprints painted with equations, and yet, when held up to the climate of reality, they behave like water in cupped hands. The closer you squeeze, the faster they leak. Start with the grandest collector of all, a Dyson-scale power infrastructure. Surround a star with a swarm of mirrors and panels, harvest a significant fraction of its 3.26 in 26 to 3 Kistos 26 watts, and energy stops being the bottleneck, or so the story goes. But the engineering stack is mountainous. Materials must endure decades to centuries of radiation, micrometeoroids, thermal cycling, and orbital perturbations. Maintenance must be continuous and distributed. Control must be ruthless across millions to billions of units. Waste heat must be dumped without boiling the local environment, and the entire system must resist cascading failures where a small error becomes a corridor of shrapnel. Build it, and propulsion still nags. Turning raw power into momentum at starship scales demands exhaust velocities near relativistic, radiator areas that don't implode the mass budget, and precision that doesn't erode under cosmic grit. Energy abundance does not annul the rocket equation. It just lets you pay larger bills for longer before the same asymptotes appear. Antimatter is the distilled seduction of energy density, pure annihilation, perfect in concept. Yet it is a currency that costs more to mint than to spend. Production requires staggering input energy and exquisite traps. Storage needs fields that never fail, and containers that never touch. Handling demands systems that treat dust motes like grenades. Even if safety were solved, the practical cycle slides you back into thermal management and momentum transfer, because annihilation yields radiation that must be shaped into thrust and heat that must be thrown overboard. At starship scales, the radiator becomes architecture, and architecture becomes drag, and drag becomes more radiator, a spiral that doesn't care how elegant the reactor is upstream. Fusion feels saner, fuel in oceans of deuterium, burn products friendlier than fission, exhaust speeds in the right neighbourhood, and still the devil nests in operational ratios. Thrust to mass at useful levels over years, with reliability that tolerates no single-point failures, implies engineering margins that balloon mass. Mass then punishes acceleration. Long burns demand colossal heat rejection, and the interstellar medium punishes high-speed hulls with impacts that scale lethally with velocity. We'll just add shielding as the forward epitaph of many designs. The shield adds mass. Mass lengthens trip times or inflates energy demands. Longer trips amplify maintenance risk. Higher energy demand inflates radiator burden, and around it goes until the word just evaporates. Laser-push sails change the game by exiling the engine. Keep the ship featherlight, keep the power source at home and ride a beam. For probes, this can work astonishingly well. For crewed or cargo-bearing arcs, the beam must be sustained across astronomical distances with sub-microradian pointing, adaptive optics through turbulent media, phased arrays that span kilometers to thousands of kilometers, and optics that survive their own brilliance. The sail must reflect nearly everything, absorb almost nothing, reject what it must absorb without wrinkling or tearing, and ride a pressure field that any misalignment converts into shear. Deceleration at destination demands either a mirror waiting for you, implausible, or magnetic or photon braking against tenuous media over brutal distances, which is to say, more time, more mass, more failure surface. The elegance is real, the scalability isn't. Warp and wormhole architectures glitter the most. They are written in respectable mathematics, sometimes even in metrics that pass the first sniff test, but they smuggle in conditions that reality refuses to supply. Negative energy densities of sustained magnitude, exotic stress-energy arrangements that skate the edge of quantum inequalities, and stability under fluctuations that would amplify like a feedback microphone in a cathedral. Even granting materials the universe has not yet shown, warp geometries tend to accumulate bow shocks of particles and fields, storing lethality at the bubble's edge that releases catastrophically when you stop. Wormholes, meanwhile, are throats that want to collapse, doors that slam unless propped open by something that behaves like a fluid with less than nothing inside it. The math invites, the ontology says, bring proof, not poetry. Then there is the governance of miracles. A civilization capable of Dyson swarms, antimatter economies, fusion arcs, or beam infrastructures must also be capable of planetary-scale reliability, ethics as robust as its reactors, and failure modes that don't end in sterilizing fallout. Every 9 added to uptime multiplies cost and complexity. Every fail-safe spawns a shadow system that must also never fail. Every layer of redundancy creates interactions that only reveal themselves under stress. The practical ceiling arrives not at impossible, but at unmanageable, a cliff where coordination, maintenance and politics claim the victory parade that physics once promised. All these mirages share a signature. They do not collapse under first-order scrutiny. They survive it, even inspire it, and then they starve under second- and third-order couplings, heat and mass and pointing and fatigue and governance and time. They are not lies, they are horizons, and horizons are valuable because they steer research, sharpen constraints, and teach humility, but they remain horizons, not harbours. So the technological mirage is not a defeat, it is a diagnosis. It says the boundary is not a single wall to breach with a single breakthrough. It is a braided cord of limits, gravity's well, the medium's grit, relativity's curve, expansion's horizon, entropy's weather, each thread tightening as the others are pulled. Cut one, the rest hold. Cut many, the last still bites. The mind rebels at that geometry and reaches for a bigger knife. The universe replies with a map the knife cannot change, which leaves the pivot that makes this story human instead of hopeless. If the outward path won't yield to even our best sketches of power, then the measure of greatness shifts from how far we go to how deeply we understand, from the size of our wake to the clarity of our seeing, from conquest to care. That isn't resignation, it's selection. It chooses a fight we can win for as long as physics allows, to read the Milky Way in full, to tend its lights, and to make meaning that does not need escape to feel infinite. Progress feels like a staircase, each step a breakthrough, each landing a triumph. So it's tempting to believe that if we just keep climbing, we'll crest the last rise and see a clear road out of the Milky Way. But some problems don't behave like stairs, they behave like spirals. Each loop brings you close to where you were, only deeper, and the limits you thought you'd left behind return with new faces and higher stakes. The paradox of progress is that the very tools that make us better at moving, building, and surviving also sharpen the outlines of the walls we live inside. The more precisely we measure, the more real the limits become. The more power we wield, the more expensive the last gains feel. The closer we get to enough, the more enough recedes. Start with speed. Early rockets taught us to leave the ground by brute force. Better engines taught us to leave Earth by geometry. Better navigation taught us to leave the solar system by thrift and timing. Each advance changed the question from can we go to how well can we go. Then physics takes the floor and replaces well with how much energy per kilogram do you have, how much heat can you throw away, how much mass can you afford to protect, and how much risk can you budget before a single failure on year 57 erases year 1 through 56. Progress made us fast enough to notice that energy scales quadratically with velocity, that radiators grow like bad news, and that every extra 9 of reliability costs a fortune in design, fabrication, and maintenance. The ceiling rises, but the room stretches too. Turn to shielding, go faster, and every atom of the medium becomes a projectile. Add armor, and mass punishes acceleration. Add smarter materials, and heat management sneaks in with its own penalties. Add magnetic fields to deflect charged particles, and you invite new couplings, new instabilities, new paths for failure. The better the materials, the clearer the trade-offs. The clearer the trade-offs, the more honest the budget. The more honest the budget, the heavier the ship becomes. Progress doesn't remove the paradox. It illuminates it until there's nowhere left for wishful thinking to hide. Consider life support. Closed-loop ecologies look elegant on whiteboards. Water recycled, air scrubbed, nutrients looped, nothing wasted. Yet time multiplies corner cases. Biofilms colonize valves with stubborn intelligence. Trace toxins accumulate in reservoirs no one thought to monitor in year 1 because they didn't exist until year 20. Genetic drift turns hardy crops into temperamental cousins who don't read the manual. Every solved failure breeds subtler ones, and every patch adds complexity that must itself be maintained. The more adept we get at sustaining life far from Earth, the more vividly we grasp that a truly closed habitat is not a machine to be completed, but a culture to be tended without intermission. Progress improves the garden. It also lengthens the gardening. Power follows the same curve. Fusion dreams become prototypes. Prototypes become testbeds. Testbeds become systems, and systems teach lessons about fatigue, impurity management, component lifetime, and the tyranny of downtime in an environment where downtime is another word for drift. Antimatter labs inch forward in picograms, and the storage that holds them whispers about quench margins and a failure mode that writes history in microseconds. Beamed energy arrays spread across orbits and deserts in concept, then meet weather, dust, thermal expansion, atmospheric turbulence, political boundaries, and the law that says every gigawatt of power must be shepherded by people, and people are not linear systems. We solve yesterday's impossibilities and collect today's vulnerabilities as souvenirs. Even communication mirrors this arc. We can squeeze bits per photon to approach theoretical bounds, cancel noise with exquisite signal processing, phase arrays across continental baselines. But the more perfectly we use the channel, the more the fundamental limits stand alone in the middle of the room, silent and unmovable. Photons still thin with distance, backgrounds still hiss. Interstellar dispersion, scattering, and stellar glare can be mitigated but not annulled. The genius in the link budget makes the remaining gap more visible, not smaller. And still, progress is real. It shortens interplanetary crossings, It makes probes to nearby stars plausible. It lets telescopes read faint light like Braille. It turns impossibilities into difficulties and difficulties into work. But watching progress at close range changes the story from ladder to loom. We weave capability into constraints, constraints into capability, the pattern tightening until the texture itself becomes the message. We don't run out of ideas. We run into the climate those ideas must live in. Gravity's well, the medium's grit, relativity's curve, expansion's horizon, entropy's weather. Each breakthrough is a sail that catches more wind. The current still flows the other way. The result is a subtler kind of awe. Not the awe of conquest, where the map gets new lines, but the awe of comprehension, where the old lines are understood so well that they become teachers. Progress makes us humble with better data, not small with fewer dreams. It reframes the mission from breakout to go deep, from the fantasy of intergalactic commutes to the reality of galactic stewardship, where the victories are measured in clarity, continuity, and care. That kind of progress accumulates differently, in archives that don't decay, in infrastructures that survive politics, in cultures that can tell the same story honestly across centuries without becoming brittle or bored. So the paradox is not that progress fails, it's that progress, when it succeeds, reveals that leaving the Milky Way is not a problem waiting for one more invention, but a boundary made of many correct answers fitting together too tightly to be pried apart. The more we learn, the less we lie to ourselves about the price, and the less we lie, the more meaningful the work becomes. There is dignity in that pivot. There is scale in that honesty, and there is a different, deeper kind of adventure in mastering an island so large that no single civilization will exhaust its frontiers, even if the ocean beyond remains, forever, a beautiful, unreachable blue. Light is the fastest thing in the universe, so it's natural to think of it as freedom. But in a galaxy, even photons tell a story about limits, because their paths curve in gravity, their energies shift with motion and expansion, and their journeys, however swift, must still obey the geometry they traverse. A beam leaving the disk aims for openness and finds structure instead. Dust that scatters, gas that absorbs, magnetic fields that twist polarization, and a gravitational landscape that lenses and delays. To human eyes, starlight feels instant. To an honest clock, it is bookkeeping across a web of tolls, each one small, all of them cumulative. No one arrests a photon. The universe taxes it until the destination is poorer than the source. Inside a galaxy, the light we see is a composite. Young blue stars, old red giants, glowing gas, millimeter whispers from cold dust, yet every channel is a compromise with matter. At high energies, X-rays tangle with columns of gas that turn bright into faint. At optical wavelengths, lanes of dust carve silhouettes across arms like bruises on a spiral. In the infrared, the dust itself glows and hides what lies behind with a warm, deceptive fog. Even radio, the great penetrator, meets confusion. Many sources blend into one, and resolution becomes an engineering arm wrestle with dish size and baseline. The map is not a canvas, it is a palimpsest. Layers written over layers, truth legible only to instruments that can read scars. Then there is motion, and with it, shift. Stars on orbits imprint their velocities on the spectrum, stretching and squeezing lines that astronomers use like fingerprints. From this, the galaxy's rotation curve emerges, flat where Newton alone would have predicted a fall, evidence that mass we do not see is keeping time with mass we do. The light is honest, our assumptions were not. Learning that lesson made us better at listening, and listening better taught us another constraint. Most of what binds us does not shine, and the part that shines is the tracer, not the driver. We are passengers on a train whose engine is invisible, and whose schedule is written in gravity's language, not ours. Even the fastest signals carry histories they cannot outrun. Photons leaving the core of a star spend millennia random walking through plasma before escaping. By the time they reach a telescope, their story starts with a long stutter. Photons skimming a black hole's neighbourhood accumulate delays and distortions that encode geometry at the cost of clarity. Photons traversing the disk pick up the fingerprints of intervening gas, absorption lines that are both a gift, measurement, and a theft, lost flux. At intergalactic scales, the same photons are stretched by expansion, their wavelengths lengthening as if tired, until what began as blue arrives as red, what began as visible arrives as infrared, and what began as ultraviolet becomes a rumour in the microwave. This is why light, the universal courier, can also feel like a cage. The messages we send, narrow beams carefully modulated, error-corrected within an inch of their bandwidth, still disperse, still diffract, still lose intensity as 1R1, 1R2, still drown in backgrounds that don't care about our clever codes. A civilization might pour a city's worth of power into a signal and watch it vanish into a sky that treats it as one more grain of sand on a cold beach. We can aim better, compress harder, stack longer, build larger, but the asymptote remains. Information rides on carriers pay the toll, and the toll rises with distance in a way no rhetoric can negotiate down. The galaxy itself is a light cage of a different kind. Our orbits define what we can see when, dust defines what we can see where, and time defines what we can see at all. Events flash and fade, supernova, flares, transits, mergers, and unless instruments are watching the right patch with the right sensitivity at the right moment, the universe shrugs and moves on. We build surveys to fight chance, synoptic telescopes to catch change like fishermen with wide nets, but nets have holes by definition. Catalogues fill and still leave blank spaces where something bright and brief once happened. To know is to arrive on time, and time is not our ally. If all of this sounds like an argument for despair, it is not. It is an argument for realism that sharpens awe. Knowing that light is taxed gives weight to every photon we catch. Knowing that dust lies makes every cleared window feel like a saved page. Knowing that background's hiss turns each detection into a triumph not of luck but of design. The cage metaphor breaks down not because the bars aren't real, but because what's inside is vast. 100 billion stars, 100,000 light years, a halo whose relic streams right the family tree of collisions and accretions. These are not scraps. They are an archive with aisles we have only begun to walk. Yet the metaphor has one more turn. A cage with bars wide enough to see through tests not strength but attention. If leaving the Milky Way is functionally off the table, then the choice is not between freedom and confinement. It is between superficiality and depth. Light will keep arriving with taxes paid and scars visible. Instruments will keep getting colder, cleaner, smarter. Catalogues will grow from lists into narratives. How stars migrate, how arms wind and unwind, how the core sleeps and wakes, how the halo whispers the names of swallowed dwarfs. The cage teaches patience. Patience teaches fluency. Fluency turns watching into understanding. And understanding is not passive. It builds. It builds instruments that correct for dust and decode velocity fields. It builds simulations that test hypotheses against the sky. It builds archives that preserve data for eyes not yet born. It builds cultures that celebrate measurement as a form of meaning. In that construction, light stops looking like the jailer and becomes the collaborator, a messenger that can't change the laws, but can carry enough truth through them for a species to find its footing. So the light cage is real, and still the room it encloses is a cathedral. The beams that enter are bent and dimmed and delayed, and still they are enough to paint maps, test theories, and anchor wonder to evidence. If leaving the galaxy is the dream that won't cash, then reading it fully is the dream that will, a conversion of desire from motion to insight, from distance to detail, from horizons to structure. In that pivot, photons are not reminders of what we cannot do. They are the currency of what we can, and the work is to spend them wisely, until the Milky Way is not just a place we live, but a story we can tell without lying to ourselves about the cost. Every spiral has a heart, and ours is a quiet colossus, a black hole 4 million suns heavy. Yet the thing that truly anchors the Milky Way is larger and slower than any single object. It is the accumulated gravity of everything, braided into a shape that does not let go. The core is the symbol, but the anchor is the whole. Arms of stars wind like weather frozen in time. The bulge breathes with orbits that cross and precess. The dark halo holds all of it inside a patient palm. To live here is to circle a center that most of us will never see, obeying a geometry that does not ask for permission because it was written long before there were eyes to read it. Near the center, orbits a calligraphy done at speed. Stars whipping around in years where our sun needs centuries, proving by motion what no photograph can show, mass hidden in plain sight, space curved into a throat. There, a close pass is a negotiation with tides, and the price of error is final. The gas that dares approach is shredded into filaments, shocked and heated until it glows, then cooled and starved by its own turbulence. Flares come and go like the breathing of a sleeper, and even in this relative calm, the Milky Way a middling AGN at best. The environment reminds you that the place where the galaxy defines itself is not hospitable to plans that require grace. At larger scales, the core's authority softens into the shared rule of bulge and halo. Rotation curves refuse to drop, the signature of mass that does not shine. Stellar streams arc across the halo like faded scars from meals long finished. Globular clusters swing through on elongated paths. Clocks older than cities, their orbits a census of the potential. Here, the anchor has texture. It isn't a single pull. It's a field, a summation that keeps time without a metronome. To leave such a system is not to cross a fence but to unwind from a music that follows you even as it fades. Imagining an escape that leans on the centre, diving inward to trade peril for speed, sounds clever until it meets the arithmetic of tides and radiation. Planetary assists work because planets are generous engines with manageable risks. The galactic core is a forge that pays in accelerations but charges in annihilations. Hypervelocity stars prove the ledger balances. Something can be flung free, but their tickets are stamped in catastrophe. Binary partners torn apart, trajectories written by chance, no steering, no brakes. It is the wrong church for careful navigation, the wrong altar for engineering, the right theatre only for nature's brutal improvisations. So the anchor is everywhere and nowhere, a curve in every orbit, a constant in every equation of motion, a quiet in the data that says this structure holds. Even our local neighbourhood, the sun's lane in a spiral arm, owes its simplicity to that distributed grip. The stable era that gave biology time to turn chemistry into language is the same era that makes escape a story told in exponentials and caveats. Stability is not free. It is purchased with binding energy, paid back over billions of years by orbits that repeat and repeat until the repetition becomes background. There is another anchoring at work, slower still: information. The more precisely the Milky Way is mapped, the more honest our limits become, and honesty has inertia of its own. Parallax charts that pin stars to three-dimensional webs, spectroscopic surveys that weigh orbits with Doppler shifts, radio maps that peel dust from gas, gravitational lenses that sketch mass we cannot see. Each dataset adds weight to the picture, until the dream of easy exit reads not as rebellion but as refusal to read the room. Knowledge doesn't make the walls taller, it turns the lights on so you can see them. If this sounds like austerity, it helps to ask why the anchor feels like a sentence instead of a freedom. A ship wants open water. A civilization, if it lasts, needs a harbour that doesn't move. The centre provides the harbour by making the ocean inside the walls predictable. The price is that the gate is heavy. That symmetry is ancient and fair. What we call confinement is also the condition for complexity to persist long enough to wonder about confinement. The anchor is a gift that happens to be heavy. The trick is not to curse weight, but to use it to build, which points to a different definition of leaving. If exit means abandoning the well, the verdict is grim. If exit means outgrowing illusions, the verdict is hopeful. We can leave the phase of our story that confuses motion with meaning. We can leave the habit of measuring courage by kilometres rather than by clarity. We can leave the frontier myth where value is always somewhere else, always farther, always after a burn we cannot afford. In that sense, the anchor does not just hold us, it orients us, reminding us where work remains honest, in mapping, explaining, preserving, and creating within the continent-sized laboratory that already exceeds every lifetime we can stack. And once that pivot happens, the core changes tenses in our language. It stops being the monster that traps us and becomes the monument that organises our home. The orbits stop being constraints and become the choreography. The halo's unseen mass stops being a taunt and becomes a riddle. We're close to answering with instruments that make darkness legible. The anchor isn't an ending. It's the reason the story can be long. Expansion sounds like freedom. More room, more space, more future. But for travellers it behaves like a thief, because the farther you aim, the faster the target recedes, not by motion through space, but by space itself, lengthening between you and everything else. Locally, gravity stitches galaxies into groups and clusters, and inside those stitches expansion is mostly a rumour. Beyond them, it is the climate, a steady wind that carries islands apart until their light stretches into invisibility and their voices fall below the floor of hearing. You can accelerate, you can aim perfectly, you can launch on time, the horizon moves anyway. Think of a boundary that isn't a wall but a speed. a distance beyond which recession outruns any ship's best effort, because the in-between keeps growing faster than closure can occur. This isn't faster than light travel in the old sci-fi sense. It's light itself losing the race because the track is being laid down under its feet, and the lanes are lengthening as it runs. Even signals surrender to this geometry. Some messages will never arrive, not because they were weak or late, but because the universe took their road away while they were on it. In a cosmos like this, reachable becomes a shrinking word the longer you wait. Inside the Milky Way, expansion is mostly academic. We are bound, and bound systems ignore the wind. But beyond our local archipelago, it becomes a ledger entry you can't cross out. Nearby galaxies that sit within our mutual gravity well remain potential destinations in principle. Most others are on rails going outward, and the rails don't care about engines, budgets, or courage. Today's sky is generous. We can still see a tapestry of galaxies at many epochs, still measure the afterglow of a hot beginning, still compare near and far like a scientist ought. Give it time, and the gallery closes rooms one by one until only the lobby remains, well lit and local. Travel inherits that closure by default. Even if propulsion solved the old taxes, mass, heat, shielding, and culture solved the human ones, purpose, patience, governance, the map itself edits options out of existence, turning ambition into archaeology. A civilization that starts late discovers that the menu of destinations is shorter than its ancestors enjoyed, not because it is less clever, but because the night itself has reduced its inventory of available futures. The universe is both the setting and the plot has direction. There's a psychological sting to this. Exploration narratives are written in the grammar of open oceans and distant shores that stand still while you row. The expanding prison rewrites the grammar. The shore moves, the charts expire, navigation becomes triage. Which reachable lights are worth the cost and which dreams must be curated rather than pursued. That kind of decision-making is not a failure of nerve. It is a maturity forced by physics, a pivot from conquest to selection, from go everywhere to go wisely and preserve what you learn. If that sounds like resignation, invert it. Expansion's verdict is also a permission slip to specialize. The work inside a single great island can be endless without being repetitive. Mapping halo streams that remember ancient mergers, reading the chemistry of stars to reconstruct the galaxy's family tree, watching the central engine breathe across centuries, tracing magnetic architectures that bind gas into filaments where new suns are born, and building infrastructures that keep knowledge alive when the wider conversation quiets. The shrinking outward choice makes the inward project larger, because there is no cavalry coming with answers from beyond the horizon. Responsibility concentrates, so does meaning. In practical terms, the expanding prison argues for timing. Do the long baseline measurements now while the far field is still visible. Bottle data in archives that survive centuries and politics. Standardize instruments so that future calibrations rhyme with today's. Teach humility as a method so that theory doesn't outrun evidence when evidence thins. The same logic applies to travel and settlement within the local continent of stars. Choose routes that compound capability. Choose targets that teach as well as house. Choose systems whose resources and stability let cultures endure without supply lines that expansion will render nostalgic rather than useful. Most of all, expansion reframes the dream of leaving the Milky Way. It doesn't merely say the price is high, it says the store closes before the purchase can clear. That is harsher than a difficult engineering problem, it's a scheduling problem written into space-time. Against that, the only honest heroics are those that refuse to waste themselves on doors that lock while you walk, and instead turn to doors that open deeper into what's already ours. The prison metaphor breaks here, because prisons don't contain continents, they contain corridors. The Milky Way is not a corridor, it's a world with weather, history, and room for civilizations to become old without becoming empty. So the expanding prison is real, an outer boundary that recedes as fast as hope accelerates, and still the interior is immense. The lesson is not stop, but aim true. Aim at knowledge that doesn't redshift out of reach. Aim at legacies that don't require resupply from a future that won't arrive. Aim at crafts and cultures that can cross centuries without confusing motion for meaning. In that aim, the universe is not cruel. It is clear, and clarity, though it refuses certain kinds of glory, leaves plenty of others on the table for anyone disciplined enough to take them. Perspective is a trickster. Change the frame, change the truth. So when talking about leaving the Milky Way, the word itself behaves like a mirage, because where you think you are depends on what you measure against, and what you measure against depends on scales the human body wasn't built to feel. From one angle, we already move at prodigious speeds. The Earth orbits the Sun orbits the galactic centre, the galaxy drifts within the local group, and the local group rides the cosmic web's slow tides, motion nested in motion like gears within gears. From another angle, none of that motion counts as escape, because every circle is a promise to return, and every drift is a fall that takes its time. Stand on Earth and leaving means crossing a line you can point to, the Kármán threshold, the edge of air. Leave the solar system and leaving means passing the heliopause, saying goodbye to the sun's wind. When the target is a galaxy, the clean edge vanishes. There is no fence to climb, only a potential that thins without ending, a gradient that nags from the centre to the outskirts and into the dark where almost nothing lives. You can be beyond the bright disk and still not be out. You can be out technically and feel no difference at all. This is not semantics. It is a lesson about how boundaries grow ambiguous as scale grows honest. Even the word centre misleads, because the Milky Way has many. There is Sagittarius A, the dynamical heart, 4 million suns of gravity. There is the barycenter of the whole local group, a compromise point decided by the dance between our galaxy and Andromeda and their retinues. There is the cosmic rest frame, defined not by objects you can visit, but by the smooth bath of microwave afterglow that marks the universe's earliest readable surface. Relative to that bath, the Milky Way hums along at hundreds of kilometers per second. Relative to our own orbits, the same motion can feel like a fixed sky and a steady year. Change reference frames, change what still means, and the idea of leaving sloshes between them like water in a glass. In one narrative, leaving is a change of address. Pack the ship, burn for the rim, cross a calculated escape speed, and file the paperwork under done. In another narrative, leaving is a change of belonging, severing gravitational citizenship, not just from the disk and bulge, but from the halo whose gentle pull is the last quiet claim on your momentum. In the first story, a ship can write success at the moment its trajectory turns unbound. In the second, success only arrives when the galaxy's pull is negligible compared to the next thing you intend to be bound to, and for long spans there is no next thing. The void between galaxies offers no alternate membership, only prolonged neutrality. This is where perspective bites. Many human stories make meaning out of borders. Cross them, and you become new. Galaxies, being patient, make meaning out of gradients. Follow them, and you realize you have not crossed but tapered, not switched but drifted. A craft may cross 1,000 light-years of sparse halo and feel like it is still in the same chapter, because the night does not change its stars fast enough to grant a sense of arrival. Progress becomes a number on a console and a faith in integrals, not a sunrise over a different shore. The psyche, thirsty for thresholds, must be taught to love slopes. Measurement offers consolations and complications. In kinematics, bound and unbound are tidy categories. In experience, they dissolve. Instruments will tell you when your speed exceeds the local escape requirement. The view will tell you nothing for lifetimes. Models will certify that your trajectory never returns. Your descendants will live and die under the same starfield, their only testimonies written in the language of velocity components and energy budgets. A mission control obsessed with labels will declare victory. A culture aboard will discover that victory feels like maintenance. Both will be right within their frames, and talking across those frames is how civilizations keep their promises without lying. This reframing matters because it changes what counts as success. If leaving is an energy inequality, then the challenge is propulsion. If leaving is a narrative, then the challenge is continuity. If leaving is a perspective, then the challenge is honesty, about what will and will not feel different on the other side of an equation. In that honesty, heroism becomes quieter, less about planting flags in new soils, more about tending meaning across long slopes where nothing dramatic happens except that you keep going without losing yourself. It also changes what never means. We will never leave the Milky Way is, from one angle, a hard conclusion about gravity, expansion and time. From another, it is a reminder that the kind of leaving we grew up celebrating, stepping over crisp boundaries into landscapes that announce themselves, does not exist at galactic scales. There are departures that satisfy equations and departures that satisfy souls. Mistaking one for the other breeds either despair or delusion. Keeping them distinct breeds sanity. So perspective is not an escape hatch. It is a tool. It lets a species reconcile two true statements, that the galaxy will hold us in a physical sense for as long as physics keeps its habits, and that within that holding there are countless real departures, of understanding, of capability, of depth, each one a border crossed in a grammar that belongs to minds instead of engines. The map doesn't get bigger when seen this way, it gets layered, and layered maps are richer guides than flat ones. In that layered map, leaving can mean moving from ignorance to fluency, from measurement to mastery, from awe that stuns to awe that steadies. None of these require a change of sky. All of them require a change of sight. And once sight changes, the Milky Way is no longer simply the thing we cannot flee. It is the place where the most honest kinds of departure remain possible, again and again, without exhaustion. Loneliness is not an emotion here, it's a geometry. Because as the universe expands and redshift stretches the voices of distant galaxies into silence, what remains visible and reachable contracts into a single archipelago of stars, and everything beyond becomes a rumour told by fossils of light. Imagine a sky that once hummed with other cities dimming room by room, until only the merged heart of our local group remains, a solitary metropolis adrift on a dark plain. In such a future, the question, who else is out there, doesn't vanish. It becomes unaskable in practice, edged out by horizons that recede faster than any reply could cross them. The cosmos wasn't emptied. It drifted apart until conversation itself broke. Loneliness on these scales is subtle. It doesn't arrive with a bang. It arrives as a thinning. Surveys lose their depth as wavelengths slide beyond detection. Standard candles lose their leverage without distant anchors. The cosmic background cools and hides beneath local noise, and what was once a universe of comparisons becomes a single case study. Without many examples, coincidence looks like law, outliers look like errors, and the urge to generalize turns from science into folklore wearing lab coats. It isn't that truth becomes unreachable, but that truths needing breadth become prey to parochial elegance. A smaller sky makes prettier stories, and more mistakes that rhyme too well with our own. Even in the present, loneliness has vectors. The speed of light is a delay machine. Every conversation with another star is years of silence wrapped around a reply, and every attempt to coordinate across bigger distances inherits latency, the way ships inherit drag. Add relativistic time dilation for the bold who sprint fast enough to make their own clocks lie, and you have a recipe where communication doesn't just lag, it desynchronizes purpose. A civilization that spreads learns quickly that unity is a local property and consensus a mirage at scale. You don't share a present, you share a protocol, and protocols can keep tasks aligned, but not meanings. Now fold in survival. Any settlement built honestly must accept the arithmetic of closed loops: food, water, air, heat, maintenance, and the psychology of continuity, memory, governance, identity. And those loops are jealous of attention. The farther a culture stretches, the more often it will choose resilience over outreach, durability over dialogue, because the margins are thin and entropy never naps. That choice isn't xenophobia. It's the conservation of care in a universe that charges interest on every distant promise. Over time, that accounting turns civilizations inward, not by decree but by budget. Against that drift, the search for company becomes archival. Techno-signatures, narrowband beacons, engineered transits, waste heat in odd spectra, must be hunted while the gallery is still open, stored in repositories designed to outlast fashions and regimes, and interpreted with methods that assume their own obsolescence and guard against it. The work is half astronomy, half heritage, preserving the possibility of recognition for minds not yet born, knowing the line may go quiet and deciding to keep listening anyway. Faith is the wrong word, stewardship is the right one. There is a sharper loneliness still, the kind that visits travellers. Crews crossing even interstellar gulfs discover that time is not a neutral medium. It edits morale, erodes rituals, amplifies small frictions into structural ones. Rotation helps, autonomy helps, art helps, but help is not cure, and missions bent on centuries must become cultures competent at tending meaning the way engineers tend reactors. You cannot schedule purpose once a week and expect it to hold. It must be built into chores, baked into holidays, woven into redundancy so that when one story frays, another carries the thread. The opposite of loneliness isn't proximity, it's coherence. And yet, The lonely future is not empty of significance. Isolation clarifies obligations. To measure while measurement is still possible, to compress data into forms future minds can decode, to build instruments that teach as they observe and archives that teach as they store, to practice skepticism without cruelty and wonder without naivety. If the universe denies us breadth later, the ethical answer is depth now, an intensity of attention that turns one galaxy into a sufficient cosmos for honest labour. Here is the quiet pivot. We will never leave the Milky Way can sound like a prison sentence because it lands on the ear trained by frontier myths, where value equals distance and glory equals elsewhere. But on the scales that matter, loneliness doesn't ask for escape, it asks for mastery of presence. A single great island of stars is not a consolation prize. It is a lifetime of lifetimes, chemistry writing family trees in stellar spectra, dynamics etching merger histories into halo streams, a central engine that sleeps and wakes on geological clocks, and planetary surfaces that may hold weather, memory, and wills of their own. Loneliness, properly understood, is the price of a universe that allows complexity to last. Horizons keep conversations local. Locality keeps stewardship possible. Stewardship keeps stories honest. The task isn't to rage at the distance, but to make the near profound, to cultivate cultures that can carry meaning across centuries without mistaking motion for purpose, to mint instruments that make darkness legible without dreaming it away, to build archives that treat data like heirlooms and curiosity like lore. If companionship from beyond fades, then the remedy is not despair. It is an intimacy with this galaxy so complete that it becomes the antidote to distance. In that intimacy, the lonely forever is not a threat. It is a setting worthy of courage. History turns to myth when evidence slips from our hands, when stories outlive the measurements that birthed them, and that fate awaits cosmology itself, because horizons will tighten, archives will decay if we let them, and the sky will simplify until the grand context becomes a rumour told by careful people to skeptical heirs. Imagine a future observatory beneath a quieter dome, its detectors reading only the merged glow of our local supergalaxy, its instruments finding no cosmic background within reach, its catalogues describing a universe that appears static, finite, and self-contained. In that world, the true story, hot beginning, web of galaxies, accelerating expansion, will survive only if we choose to carry it like fire. This is not a thought experiment for poets, it's logistics for civilizations. Data rot is as real as rust, formats die, media delaminate, compression schemes become puzzles no one remembers how to solve. The first duty, then, is custodial, replicate the record across time, space, and culture. Redundant repositories with independent power, error-correcting codes that can be rederived from first principles, Rosetta-style guides that teach the units, constants, and conventions embedded in the numbers. Preservation isn't storage, it's pedagogy frozen into hardware and prose. A library that cannot teach itself to an alien mind, future or foreign, is a mausoleum pretending to be a memory. The second duty is skepticism with a long half-life. Methods must be preserved alongside measurements, how instruments were calibrated, how biases were modelled, how priors were chosen, so that theories do not survive as slogans. When the sky grows parochial, beautiful wrong answers will multiply. Without careful scaffolding, descendants will fit local data with elegant curves and declare victory over a smaller cosmos. The antidote is provenance so rich it can be audited by strangers, and curricula that teach the joy of being corrected by evidence you cannot personally recollect. In a lonely future, humility is not modesty, it's infrastructure. Then there is the craft of instruments that age gracefully. Build telescopes and labs that teach as they operate, devices with embedded tutorials, self-diagnostics that demonstrate their own limits, calibration artifacts that explain units without trusting institutional memory. Write the constants on the walls, engrave the meter and the Kelvin next to the mirrors. Leave behind not black boxes but transparent puzzles that reward reconstruction. In a time when confirmation by new distant data is impossible, reconstruction of old understanding becomes the experiment. The lab of the future is also a school that refuses to die. Myth creeps in at the edges of meaning, not just measurement. Frontier epics fade when frontiers recede, and cultures will be tempted to replace cosmology with cosmography. Maps without time, structure without story. The remedy is narrative honesty. Teach expansion as fate, entropy as climate, horizons as laws, not to depress, but to orient, to convert awe from the rush of discovery to the depth of comprehension. If the universe denies breadth later, the noble pivot is to deepen inward, to make a single great galaxy sufficient for wonder that does not cheat. That is not settling. It is choosing scale without surrender. A counterpoint. Myth need not be the enemy. In every era, metaphor carried science across the void between mind and math. The danger isn't story. It's when story stops being corrigible by fact. A future cosmology worth the name will braid ritual to remembrance, anniversaries of first light detections, pilgrimages to preserved arrays, ceremonies that rehearse the constants and the questions. Make the practices sacred so the content stays secular. Shield the truth inside traditions that honour revision. That paradox is how fragile knowledge survives long winters. And winters will come. Political ones that starve budgets, cultural ones that tire of the slow burn of precision, material ones where maintenance outruns manufacture. In those seasons, the burden shifts to redundancy of meaning. Multiple communities holding the same flame for different reasons. Engineers because the methods are beautiful, artists because the images are, philosophers because the implications are, citizens because the inheritance is theirs. A monoculture of curiosity is brittle, a polyculture is resilient. Build the latter on purpose. Finally, accept that some losses are permanent and plan dignity around them. Not every dataset can be kept. Not every instrument can be entombed and revived. Choose what to save the way field biologists choose keystone species. Archives that scaffold others, primers that bootstrap units and logic, exemplars of method that let future minds climb back to the cliff where we once stood. And write, everywhere, the clause that matters most. These conclusions were true when the sky was larger, and they remain true even when the sky is small. This is how cosmology becomes myth without becoming a lie, by admitting the narrowing of horizons while refusing the narrowing of thought. The end of breadth can be the beginning of depth. The end of easy confirmation can be the beginning of careful remembrance. The end of conversation with the far field can be the beginning of an ethics of attention at home. If departure is denied, then fidelity must be embraced. Fidelity to methods, to records, to the quiet courage of staying true in a universe that slowly edits away the evidence of its own origin. In that fidelity, the story does not shrink. It becomes precise. And precision, kept warm across centuries, is a kind of immortality. Hope is not a plan, but it is a fuel. And when the destination is beyond physics, the work is to refine hope into something burnable. Purpose that survives delays, rituals that survive leadership changes, cultures that survive their own success. Picture a civilization that accepts the verdict on leaving the Milky Way, not as a surrender, but as a focusing lens, turning ambition inward without dimming it, redirecting the drive that once pointed at far shores toward mastery of a single, inexhaustible continent of stars. The emotional arc needs a new grammar, not conquest, continuity, not farther, deeper, not speed, stewardship. That begins with an honest ledger of human limits. Bodies are tuned to gravity wells and sunrises, to seasons and faces. Stretch those rhythms and strain appears. Sleep drifts, mood frays, memory blurs, attention narrows. Crews in isolation adapt, and adaptation is real, but it is not free. It demands structure the way a reactor demands cooling, constant interventions that keep cognition and cohesion within bounds. Over decades, that maintenance becomes culture by design. Light schedules that choreograph circadian health, habitat acoustics tuned like instruments, shared labour that dignifies the boring, and private space protected like oxygen. You cannot bootstrap meaning in a crisis. You build it when things are calm so it's ready when they aren't. Attention turns next to narratives that don't expire on a single watch. Missions fail when success hides beyond lifetimes, unless the story blesses caretakers as authors, not placeholders. So rites matter, handovers that are theatre on purpose, anniversaries that rehearse first principles, calendars that bind technical tasks to communal time. The goal is not sentimentality, it is redundancy. If one thread of purpose frays, glory, discovery, pride, another holds, craft, service, inheritance. Coherence beats charisma across centuries. Ritual beats inspiration on long roads. Then comes learning as infrastructure. An interstellar society without a frontier myth must convert curiosity into policy. Archives that outlive regimes, instruments that teach their own use, standards that explain themselves, apprenticeships that defend rigor from fashion. Each generation should be able to recover the operating system of civilization from the backups, even if the previous one drops the manual. That means writing constants on walls, units, priors, calibration histories, and building institutions that are hard to capture and easy to audit. Knowledge must be stored like seed and defended like water. Stewardship is the shape of the new heroism. 1 billion worlds may never be reachable, a few thousand might be, enough to matter forever. Choose targets as teachers as well as homes, systems with diverse chemistries, architectures that test theories, habitats that can bootstrap local industry without a constant subsidy from elsewhere. Spread slowly on purpose, matching expansion to comprehension so the frontier doesn't outrun wisdom. And when a settlement must fail, let it fail like a stage of a rocket. Clean separations, intact records, lessons captured with tenderness rather than blame. Or must be retrained too. The quick hit, launches, first lights, flag on regolith, won't disappear, but it won't be enough. All that lasts is quieter. Long integrations that reveal a Halo Streams thread, spectra that turn starlight into a family tree, timing arrays that catch a black hole's heartbeat across years. Teach that kind to children early, and the culture's dopamine finds nourishment in patience. A species that can be thrilled by data will have no shortage of thrills. Ethics thickens under distance. Fewer eyes mean more room for error. Slower feedback means mistakes propagate farther. Richer tools mean consequences are larger. So the code must be heavier than law and lighter than dogma. Principles that survive translation, checks that survive capture, humility that survives success. The galaxy is old. Wisdom must be older than any one moment. A society that knows how to say no to itself will keep more doors open than one that never learned how. Finally, hope must be grounded in acceptance without becoming small. Accept that horizons recede and that some shores will never be reached. Accept that time edits options. Accept that leaving the Milky Way is a dream that reveals more about yearning than about engineering. And then, with acceptance as bedrock, build a civilization that is not a consolation prize, but a masterpiece of staying. Lights tended across orbits and centuries, libraries that can reteach the sky to the future, instruments that turn darkness into sentences, farms that turn starlight into dinners and poems, courts and choirs that make longevity humane. The harsh reality was the hook. We will never leave the Milky Way. The human answer is the pivot, so we will make the Milky Way worth never leaving. We will map it like a promise, learn it like a language, garden it like a world that chose us as much as we chose it. And if the universe grows quiet, then our songs must get better, because the audience is smaller and the stage is all we will ever have. The epic does not end at the walls, it begins when we agree to live beautifully within them. Endings clarify beginnings. So if the harsh truth is that we will never leave the Milky Way, the tender counter-truth is that the Milky Way is enough, not as a consolation, but as a canvas vast enough to spend a species on without wasting a minute. The old dream of flight beyond our island was never really about distance. It was about meaning, about proving that curiosity is stronger than fear, that patience is stronger than time, that intelligence is a promise kept. We can keep that promise here. We can keep it beautifully. We can keep it for as long as the stars allow. So let the epic pivot. The hook is not elsewhere. It is us, the animal that learned to read starlight, to peel spectra into elements, to weigh gravity with orbits, to map a halo by the scars of swallowed worlds. The plot is not escape, it is fidelity, building instruments that turn darkness into sentences, archives that outlast fashions, habitats that make long life humane, and cultures that can tell the truth across centuries without growing brittle or bored. The set piece is not a jump to another galaxy. It is a slow unveiling of this one, the central engines breathing, the arms winding and unwinding, the halo's fossil rivers, the quiet births and violent endings of suns. Let the hero shot change too. Not a ship knifing through exotic geometry, but a telescope blinking awake into new frequency bands. A survey that stitches night into time-lapse. A data release that gives 1 million minds the same sky to read. a council that chooses stewardship over spectacle, a school that teaches children to love long integrations and honest error bars. Make wonder compatible with rigour. Make patience glamorous. Make continuity the new audacity. And when the future narrows, when the horizon recedes, when distant beacons fade into silence, let that be the cue to tend the lights at home with twice the care. Bottle today's deep sky for tomorrow's smaller dome. Engrave the constants beside the mirrors. Build instruments that explain themselves to strangers. Write methods that can be reconstructed from scratch. Tie memory to ritual so the truth stays corrigible instead of calcifying into legend. If the conversation with the far field goes quiet, keep speaking in a voice worthy of being overheard by the only audience guaranteed to remain, our descendants. There is one more vow to make, and it is not about technology. It is about kindness as strategy. Long projects require soft hands, institutions that don't eat their young, teams that reward repair as much as invention, leaders who measure glory in continuity rather than conquest. The galaxy is a long game. Only gentle players finish it. Teach that as law, that keeping the flame is a greater art than lighting it, that the romance of the first time is nothing without the courage of the thousandth, that staying true is the hardest and most beautiful form of motion a mind can manage. So here is the ending that starts the work. We will not flee this island. We will name it. We will learn its grammar until our metaphors fit its math. We will map its memory, the collisions it survived, the stars it raised, the rivers of light it braided through a dark it made gentle. We will plant gardens beneath steady suns and read the wind of magnetic fields like weather, and we will accept horizons not as insults but as scales, tuning ourselves to a music written for patience. And when someone asks, as they always will, why the story still matters without the last impossible leap, answer simply, because the story was never about the leap. It was about the gaze that could cross 100,000 light years without moving an inch, the hand that could build with truth as a tool, the heart that could choose depth over distance and still find endlessness waiting. The galaxy is our covenant. We will keep it. We will keep each other within it. And the epic will not diminish. It will finally become honest, which is to say, infinite in the only way that counts.